Okay, so we'll start. So our next speaker will introduce us with subtitles in HTML5. Please welcome Andreas Stein.
Thank you. It's also subtitles in XML. You already heard that I like XML. XML is great. I'm from the IIT. IIT is the Institute for Rundfunktechnik in Germany. It's an R&D organization funded by the public broadcasters in Germany, Switzerland, and Austria. And we've been doing some work on imscJS as part of the European project Immersive Accessibility. We're working with partners so that access services get appropriate representation in immersive media, especially in 360 degrees. And you will see later how we plan to make this happen with imscJS. So this is my third talk here at the Open Media Room of FOSDEM, and my talks is always around how open source can help adoption of standards. And the last two talks, they were more in the direction, I would like to see it this way. And I think with imscJS, I think we are already pretty there where I think open source can help standards and standards can help open source. So imsc stands for Internet Media Subtitles and Caption. It's an XML format for subtitles. It's based on the time-text markup language of the W3C. It's a subset, a profile of TTML. So all imsc documents are also TTML documents. If you heard of EBU-TDD, that's also a subset of TTML specified by the EBU, the European Broadcast Union, who also co-organized this event. So imsc is a superset of EBU-TDD. So if you have an EBU-TDD document, it's always also an imsc document. So an imsc renderer will always render EBU-TDD. So imscJS is written in JavaScript. It has a pretty free open source license, BSD2. And because it covers pretty much of what you would do with TTML, it's not only an imsc renderer, it's a good TTML renderer. And because it has not only a text profile, but also a profile for images that may be useful if you do not have the font available on the device, especially if you want to deliver some Asian languages or subtitles in Asian languages, then you may use the image profile. It's, of course, hosted on GitHub, and the author is Pierre Lemieux, and Pierre Lemieux is also the editor, the responsible editor of the imsc spec. His work for standardization, but also for imscJS, is sponsored by Movie Labs, and Movie Labs is an R&D organization funded by I think 6 major Hollywood studios. So I picked 3 use cases for imscJS I want to look at. One is for reference, so how you can use imsc as a reference implementation, how it can bridge the gap in HTML5 as polyfill. In just one slide, I would just point out some ideas how you could use imscJS as a toolbox. So what is the value of a reference implementation? Some developers, I see also some developers here in the room, don't like to read long, complex standards and work through it. They really like to work by example and learn by example how to implement it. So therefore, you need a reference implementation that does the right thing with some input. So for imsc, you get some XML subtitle documents, and it renders the correct subtitle presentation, and some developers prefer to implement some standards. But This could be done also with something that is not open source, it's just free, and you have access to it. But the value of open source here for reference implementation is that you can also look under the hood, and you can see how it's done. It's a guidance also how to implement. It shows you in algorithmic form how the standard is built up. And I have to say, after looking in the code of imscJS, that I learned a lot about the standard myself. And last but not least, of course, you can integrate it in your existing systems and software as you like, especially if you have a free license like BSD. So what are the process steps of imscJS? Of course, first it needs to be parsed. It will be translated in a object model. So you have the document as one object model. Then from that object model, you can, for every point in time of the playtime of the video, you can generate a presentation, a static presentation of the subtitles. It is called ISD. I come later to that. And at the end, of course, you want to render it out somewhere. And I look at it if you want to render it out to HTML, so that you generate an HTML doc fragment from the ISD. You can build the imsc code with a grunt script to one file. You would normally use that if you use it in the browser, but you can also use it with Node.js. It's written in modules, and the parsing model is doc.js, the ISD generation model is isd.js, and HTML.js covers the function of rendering. So first, parsing. That's quite simple. I assume you build imsc from code with grunt, and then you have an imsc object, and the imsc object as properties has the main functions that you need. And one is from XML. You give it an XML string, and then it generates this JavaScript representation of the XML document. And pretty simplified example how it looked like. For example, on the console, if you want to see what is in there. It not only rebuilds the structure, it also already do some helping stuff. It resolves the times, so there are different time expressions possible in HTML. So it all translated to media time in seconds and fraction of seconds. And it does some other helpful stuff that eases processing later. So ISD generation, what is ISD? ISD, oops, not too much. ISD stands for Intermediate Synchronic Document. I give an example to show why you need it. So if you have word-by-word subtitles, you may know it from US captions and also from some live UK subtitles, then you would also did possibly like that. So you want to have I am at FOSDEM coming up word by word. You start with the I and then leave it on screen for the complete time, which is 3 seconds, and at the M start at 1 second and at FOSDEM at 2 seconds. And this could happen pretty much everywhere in the document, so you could have a lot of different content elements having different timings, and at rendering you really do not want to track all these different independent time content elements, so you want a static representation of what happens at a certain time. So you want a representation at 0 seconds where just the I would be in the content element and the P in the paragraph is, in this case, in 1 second it will be I am, in 3 seconds it will be I am at FOSDEM. So in the intermediate synchronous document, everything what is not relevant at a specific point in time where you want the result of the subtitle rendering plane, it's pruned out and you got just what you need to render. And then you can do whatever you want. Pretty simple what to do with imsc. You use the function generate ISD. You gave it the JavaScript model you generated before, the offset you want, every offset that makes sense for the so from the beginning to the end of the playtime of the video, and then you get this ISD representation. It looks like that. So it's similar to what we've seen before, but all times are gone. So the ISD has no time at all. It's just a static representation of the rendering plane of the subtitles. And what is also done with this step that's done by imscJS, that all values for style attributes are computed. So there are different ways, for example, to specify color. You can use hex code or RGBA with decimal, or different values for text alignment. So all this is then normalized and in the ISD document. So at this point, you could render it out as SVG. You could do it whatever you use in your player. But I think a pretty obvious use case would be to render it as HTML. So you need a wrapper element where you hook in this generated subtitle DOM fragment. Usually you would use, I think, a container where you have the video element in, and then use this container element as wrapper. But you could also just create one element, and then you give it the function render of imsc, give it the ISD you generated before. This element, this wrapper element, and if this wrapper element does not have explicit height and width, usually it would have, I think, then you need also to provide this as parameters for the function. So this is how it looks like. All the HTML-specific style properties are mapped to CSS as inline styles, with pretty straightforward, but still some tricks you have to do. So it's really good to look at HTML5 if you want to do it yourself. imsc HTML is not natively supported by browsers. Nonetheless, by a lot of people, possibly not all will agree, it's seen as part of the web platform. So if you want to have to support it, you need a polyfill. So a polyfill is not only there that older browsers support some new stuff, it's also there to have some new features or unsupported features of the web platform are supported already in browsers. So, and here imscJS does exactly that. It gives you the opportunity to use our HTML in the HTML5 ecosystem, and it does it quite well. And how could you do it? It's really super simple. I assume you have a video element somewhere. You got it already in the view variable. You add a track to the video, and then you have two choices possibly. You first go to every point in time where some subtitle presentation changes. So imsc has also the get media times function that gives you an array of all these different times. So you iterate through that, and every time something changes, you then you create a VTT queue with their appropriate times, begin and end. So the time itself and the next time when something changes, or you already know that you have simple subtitle block with begin and end, and then also from the media time it's quite easy to figure out where's the begin and where's the end, and then you generate the VTT queues from that. And of course nothing in the text. You don't want that VTT itself to render it. We just want the queue and track implementation. So what we want is to use the callback functions that can be used together with the on-end and on-exit events of the queue So every time the queue starts, you would generate an ISD, and you render it out. So that's all. So that here goes your subtitle renderer in your video player. And of course, you should not forget on exit to remove it again from the wrapper element. And then at the end, add it to the text track, of course. So I just touched briefly how to use imscJS as toolbox. Possibly you do not have a HTML document, or you have a really static presentation of your subtitles, so you may not want to always generate the ISDs from the HTML document because it iterates quite a few times over the structure. So you can use an ISD directly and just manipulate the text, for example, or the position or whatever. So that would be quite simple. You actually could use also WebVTT. You can load it in the text track and then iterate over the text track queues to just change the ISDs and use imscJS for that. You also can server-side rendering of HTML fragments. As said, you can use it with Node, and to generate the DOM fragments, of course, you need some DOM environment on the server side. And I think JS DOM would be the first choice for that. So drink some water. So it's used already in operation. So, and the most popular and common known framework that use it is -JS. Solen and EBU, they did some subtitle implementation in -JS. Solen presented it 2 years ago in the Open Media Dev Room, and now -JS replaced the subtitle rendering of HTML with imscJS. You can see it live on the IIT demo streams for CMAF, or subtitling.iit.de/CMAF. There's some recorded live stream, and there's a real live stream from Bavarian Broadcast. And and the real live stream, you can watch it also outside of Germany if it has no geo-blocking in. I come back to the Immersive Accessibility Project. We are thinking about how to present subtitles in 360 degrees. So a colleague of mine, Peter Topesch, he worked with imscJS. He did exactly what I said before. He took the ISD and just changed the position. So because if you have, for example, some position subtitles, that should stay regardless where you are in this 360 degree environment, then you need to change the position based on the user actions. So for example, if somebody is playing a guitar and you want to indicate for deaf and hearing subtitles somebody is playing, or there's some guitar music, you place it next to the guitar player, and if the guitar player moves left or you look right, then it moves together with the guitar player to the left. This is already working with imscJS and works pretty well. If you have some interest in that use case, I think my colleague Peter Topesch will be happy to get some feedback, or just email him, and so you can discuss other use cases. Okay, so I'm already at the end. I have 54 seconds to go. I will use that. Here are some links. No, there are some links for the imsc specification, imscJS. There are also other open source projects working on. I see I made a problem. Mistake. Okay, there's the time text toolkit. There's the live toolkit. It's of course not the imscJS link. It's a different one. I replace it in the slides. They're not uploaded yet on FOSDEM. Sorry for that. I will do that later. And there's a subtitle conversion framework also on GitHub. Okay. Done.
Thank you, Lars. We still have 5 minutes for questions. Is there any question? I have a mic. I'll jump. If you can pass the mic.
I see you use HTML, but it seems like WebVTT is used a lot on the web mainly. So what's the reason for using imsc in a HTML-based format when, especially towards the end users?
I actually had some slides in my presentation that had the headline questions I would ask, and one was, what is about WebVTT? Because this comes up, of course, every time. WebVTT has been chosen by the browsers as the subtitle formats they want to support. For a lot of organizations, our DVB, EBU, SMT, ATC it's very important, Hollywood studios, it's very important to get a certain quality of subtitles guaranteed, not just text on the screen. So they have chosen HTML to do that. And if you want some guarantee of presentation that works all over devices, I think imscJS and HTML are possibly, from my point of view, the better choice, because we have very different implementations at the moment from WebVTT. Maybe that changes in the future. And also not all features are supported. So, and what is also very important for our shareholders, who are the broadcasters, they want to not change format. So they will also produce, most possibly, their subtitle in the future in HTML. BBC already does. So therefore, they have no loss of transformation if they also use HTML for presentation. Does it answer your question? Thank you. There's another question.
Hi, thank you. Do you have support for multilingual streams?
Yes, I mean, this is not a feature of HTML itself. So in one document, you can't have, you can have possibly, but it's not designed to have more than one language in the subtitle document file. But what you would do normally with streams is to have different tracks, or you use dash and HLS, and you will have different, representation, I think representation sets for Dash.js, for Dash. So it will not be solved actually by the subtitle format itself.
One last question, maybe? No? Okay, thank you, Andreas.
Thank you. Thank you.